Unit 1-7, inverses. Alright, so what is an inverse? Well, an inverse is a special equations that lets you work backwards from y's to x's. Alright, so inverses are special equations that let, that's supposed to be let, you work backwards from y's to x's. We'll get to what that means. Alright. Now, to see if a function has an inverse, alright, if you remember back to sets, we have set ABC, and this is our domain. And then we have set, let's say 1, 2, 3, and this is our range. Remember, with mapping, you mapped items from your domain to items in your range. Okay. Now, this is a function because we only have, the elements from our domain are only matched with one item from our range. Okay, as indicated by only one arrow coming from each item in the domain. But now, let's see if this has an inverse. Well, we have to ask ourselves, if I know that the answer is 1, what is the original domain value? Okay, I'm going to write that down. If I know the answer is 1, what is the original domain value? If you can answer that and only have one answer, your function has an inverse. But if you answer that and you have two different answers, your function does not have an inverse. So in this case, our function does not have an inverse because if you look at the 1 in the range, it is mapped to both the A and the B from the range. So this has no inverse. All right, this has no inverse. All right, because two items from the domain are matched to the same item in the range. So therefore, we have no inverse. Let's see what this looks like graphically. All right, so let me draw a graph. I'm going to draw y equals x squared, or at least as close as I can get to it. Close enough. All right, so this is y equals x squared. All right. Now, as you can tell, all right, let's say this is -2, this is 2, so that would make this 4. All right. If I looked at the graph and I said my y value is 4, what is my x value? Well, if you look, you have 4 over here, and you have 4 over here. All right. So that would give you -2 and 2 as your answers. So therefore, this function has no inverse. Now, when you have a graph, if you remember, the vertical line test tells you if it's a function. So if it's 1-to-1, 1 from your domain matched to 1 in your range. Now, to tell if your graph has an inverse, you do what's called the horizontal line test. meaning you draw a horizontal line, and if you can position this line anywhere on your graph and hit the graph in 2 or more places, your graph does not have an inverse. Even though it's a function, because y equals x squared is surely a function, it does not have an inverse, because when you ask yourself, the output is 4, or my y value is 4, what is my original domain value? You get 2 answers. You cannot get 2 answers. All right? Let's look at another example. The question here is, does this graph have an inverse? Does this have an inverse? Let's try the horizontal line test. Let's bring this bad boy over here. Are we going to hit this graph anywhere we put this on this graph? Are we going to hit this graph in more than one place? The answer is no, it's not. So this does have an inverse. Dose. That's not what I meant to write. This does have an inverse. All right, so if you have mapping, you look at your mapping. If more than one item from your domain is matched with the same item in the range, even though it's a function, that it does not have an inverse. When you have a graph, if it fails the horizontal line test, your graph does not have an inverse. All right? So, like I said, your inverse gives you a way to work backwards. The way I describe it is it's undoing what you did to x in the first place. All right? So we're trying to get back to x. It is undoing what you did to x. All right? So let's go over the steps on how to find an inverse. So finding inverses by hand. Finding inverses by hand. Say you have an equation f of x and you want to find its inverse. All right. Here's the steps. Change out f of x for the letter y. So change out the f of x for the letter, oops, it's an L, y. Number 2, swap every x for y and vice versa. So swap every x for y and vice versa. So you change your y that you just put in for the f of x, you change that y to x, then you go to the other side of your equation, all of your x's, change them to y's. All right? Next step. Step 1, step 2. Step 3, solve for y in the new equation. Solve for y in the new equation. So you have x equals this function in terms of y. You're going to solve that new function for y, so you have y equals your function again. All right? And then the last step, change the y for the symbol f, the little -1. That right there indicates that it's the inverse, so don't forget the little -1. So the inverse of f of x. All right. It looks just the same as the original symbol for a function f of x. But like I said, it has that little -1. Don't forget that -1. That -1 is important. All right. So let's put these steps to work. All right. Let's put these steps to work. Make sure you write these down because I'm going to refer to these as we're going along. All right. So here we have a function f of x equals 3x minus 5. All right. We want to find the inverse. Yeah, I don't know what I was trying to spell right there. We want to find the inverse. All right. So first thing, it says change out the f of x for y. So now we have y equals 3x minus 5. Step 2, swap every x for y and vice versa. So now change this y into an x. Change this x into a y. Number 3, solve the new equation for y. So now we're going to solve for this y. So we're going to add 5 to both sides. So x plus 5 equals, that was supposed to be a 5. I'm thinking ahead and I wrote what I was thinking, not what I should have. X plus 5 equals 3y. Divide by 3 because that's our next step. So y equals x plus 5 divided by 3. And now the last step, you change the y for the inverse of f of x symbol. Now remember how I said it was a way of undoing what you originally did to x? You see how up here we have 3 times x minus 5? So we're multiplying by 3 and subtracting 5. Well, down here, if you look, instead of subtracting 5, now we're adding 5, and we're dividing by 3. Okay? Now, there's 2 ways to check to make sure you did this correct. The first way is go to your original equation. So in our case, f of x equals, 3x minus 5, and evaluate it at a number. Let's pick 2. So we're going to have 3 times 2 minus 5, which is 6 minus 5, which is 1. So f of 2 equals 1. Now, so your x was 2 and your y equals 1. Now, flip these around. Make your x equal 1 and your y equal 2. Throw it back into and then throw that into your inverse. So the inverse, all right, of the inverse function evaluated at 1, so 1 plus 5 over 3, which equals 1 plus 5 is 6 over 3, which equals 2. All right, so the inverse of f equals 2, so it works. We did the problem right. Now, what else you can do to make sure you got it right is, you remember the composite functions we just went over? Take f of the inverse of f of x. This should equal x. If it equals x, you did it right. If it doesn't equal x, you did something wrong. Either you found your inverse wrong, or you found the composition wrong. So, let's do this. 3 times x plus 5 over 3 minus 5. All right, now, multiplying this through, these will cancel out, leaving us with parentheses x plus 5 minus 5. Well, now the parentheses are useless, so let's scratch them out, get rid of them. 5 minus 5 cancels out. Bazinga, we got x. So, 2 ways to make sure you did it right. You can either take the composition of f with the inverse, and if it equals x, you did something right. Or you can do like we did up here. Evaluate your original function at a number, then get the y value out, switch the x and y values, and evaluate your inverse, and you should get the same thing. If you do, you did it right. If you didn't, you did something wrong. Go back and check. All right? So